This problem is a little different than a lot of the other pulley problems we've looked at because in this system there are two different chords. And right here, the green is one chord, and then this blue represents another chord. So we have two chords in one pulley system. And the method we are going to use for analysis is the same that we've been using before, except for each chord we have to write a separate equation. So first we establish a reference datum, and this is a good point. Right here, it's connected to a fixed point, and we're interested in how far away A is. So we'll call this positive. The positive direction is going down, and this will be SA. We're interested in the location of this pulley because it moves with respect to time, so we'll call this SC, and we're interested in this pulley right here. It also moves with when the rope is pulled, so we'll call this SB. So here we've identified all the different parts of our system that move, and we know that B moves up at 6 meters per second. So our velocity of B, it opposes our positive convention because our positive convention is down. So VB is moving at minus 6 meters per second. So first we want to start and we want to trace our first chord. Again, we are going to ignore this length over the pulley right here and this length over the pulley right here. These lengths are constant and will not change. The amount of chord over the pulley will not change with respect to time. So what we do, we start at A and we just trace the pulley. So right here we have a length of SA. Right here we have a length of SC. And right here we have a length of SC. And this length of the pulley is also constant. And this is equal to the length of our first chord. So this can be chord 1. If we simplify this equation, we get SA plus 2SC is equal to L1. And when we differentiate with respect to time, we get VA, the velocity of A, plus 2 velocity of C is equal to 0. And we get 0 because when we differentiate a constant, we get 0. Now, we don't know anything about the velocity of C right now. We've been given the velocity of B. So we need to look at equations for our second chord, this blue chord right here. And this is chord 2. And we have to relate these two chords to each other. So with chord 2, if we start right here and we trace the length of our chord, ignoring this distance and ignoring this distance because they're constant, we get a length of SB minus SC. So this length of the pulley right here is the length of SB minus SC. So SB minus SC plus a length of SB is equal to length 2, L2. So when we simplify this, we get 2SB minus SC is equal to L2. And we can differentiate this with respect to time and get 2 times VB minus VC is equal to 0. Now, we have an equation for VB, so VC is equal to 2VB, so this is equal to 2 times minus 6 and this is equal to minus 12 meters per second. And what this means is VC is moving at this pulley right here is moving at 12 meters per second in the upward direction. It's moving up, and it's negative because it's opposing our positive convention. So 12 meters per second up. And what we get with this equation, we get what VC is equal to. So we now have what VC is equal to. We can plug into our first equation right here. So we get VA is equal to minus 2VC, and VA is equal to minus 2 times minus 12, and this is equal to 24 meters per second. And this is positive, so we know VA is moving in the downward direction. So this is 24 meters per second down. So whenever you have two chords, this is generally what you do. You find the equation for both chords, and depending on what you're asked for in the question, you might need to solve one of the chords, get a piece of information from it, and plug it into equations you get from the first chord.